Hello, hello. Happy Wednesday, everyone. I hope you are all well. As you know, my name is Hugo Barona, and today we are back with the Cloud Lunch and Learn sessions. And today we have a special guest with us that is going to teach us all we need to know about optimizing web apps with Azure functions. I just welcome on stage Nick. Hi, Nick. How are you doing?
I'm great, thanks. How are you doing?
All good, all good. Thank you very much for your availability to be here and contribute to this user group. I, without further ado, I just give you the stage and I just ask you if you want to share your screen, please, so then you
Sure.
can get going with the session.
Will do. Let me just share my screen then.
In the meantime, let us know in the chat. If you have any questions, feel free to share your questions in the chat. Nick will be answering the questions. I'll be also monitoring the chat and help out as much as possible. And let us know as well where are you coming from and connecting with us so we can share and get to know each other a bit better. I'm just enabling the screen and the stage is all yours, Nick.
Thank you so much. Well, thank you so much for inviting me, and I'm really excited to talk to you guys today. This is my first Cloud Lunch and Learn, yeah, really excited to be here. And as Hugo said, I'm going to be talking about how you can use Azure Functions to optimize your web apps. So this isn't really a generic demo about Azure Functions. There will be a little bit of a background about what it is and what it can do for you. But what I'm going to do in this talk is refer to some specific use cases that we've applied in a business that I work for, which is Nextbotics. But before I do that, I'll give you a bit of a background about me. So I'm Nick. I'm the Director of Software Engineering at a company called Nextbotics. So Nextbotics is a robotic process automation vendor. We specialize in professional services for customers that are looking to automate their business processes. And as part of that, we have a technology which is what we call human in the loop. So during an automation, if something breaks, if something doesn't follow a particular business rule, we've got a portal which can be posted into, and users can tell the bot what to do next. But also as part of that, we've got some analytics. So we track what the telemetry is saying that's coming from the bot. We try to return information about return on investment, and the general performance of the automation. And so that is the foundation for the use cases I'm going to be talking about here when we're talking about how we optimize web apps. A little bit more about me. I'm a Microsoft MVP for developer technologies. So my background is largely in .NET. I'm a C# developer, but I also work in full stack. So I work with JavaScript, I work with Python, ASP.NET, Blazor. All the really interesting things that are coming out of Microsoft at the moment are all around things that are not just in C#. So I'm interested in all those areas, but particularly as well Azure, hence the reason for us talking about Azure Functions today. And I'm also a tech content creator on YouTube. So I make a lot of videos about the generic .NET ecosystem. So I talk about beginner topics for C#. I talk about more advanced topics around interoperability between other systems. And I also talk about Azure and the specific use cases for Azure resources in a similar way or similar content to what I'm going to be delivering today. I'm a specialist in robotic process automation, which I guess makes sense working for an RPA firm. But basically, my background with .NET has been coupled with automation specifically. So I'm very often looking at how we can use things like Azure Functions to streamline a process, a repeatable process that may have previously been done by a human and now could benefit from automation or at least human-bot collaboration. And I'm from Stoke-on-Trent in the UK, so anyone here who's not from the UK might not be familiar with Stoke-on-Trent. It's near Manchester, if that helps, sort of in the north of England, and I live there with my wife and daughter. So what are we going to cover in this talk? Well, first of all, we're going to look at what Azure Functions are. So we're going to give a generic sort of background to the technology. Again, it's not a topic which is going to be doing the fundamentals of Azure Functions, but I think it's useful for us to fully understand the use cases if we understand a little bit about the technology and what it entails. Then we're going to look at the different function types. So Azure Functions has a variety of function types, from web triggered to queue triggered. It's all usually centered around how they're triggered and how they're scheduled. So we'll look at the different types of Azure Functions that you can use. And then once we've done that, we'll go into the example use cases. So I've got 2 use cases, and I'll give you some background as to what was entailed in those use cases, how we tackled the development challenge, the development problem we needed to solve, and the results of that as well. And those 2 use cases specifically are a dashboard optimization use case. So taking data that we display on a screen to a user and making that display in as fast a time as possible and as accurately as possible. And then also a data export example. So using Azure Functions to, again, take some data and convert it into a convenient format for future manipulation. So our first topic then, what are Azure Functions? So some of you may have come across these, some of you may be using them. But for those of you who aren't familiar with Azure Functions, they are a pretty fundamental part of Azure's offering in the cloud. Most cloud providers offer an equivalent, but they are what we refer to as serverless technology. So the benefit of serverless is that they can be deployed without requiring you to have heavy maintenance of the infrastructure. Now, you may think, okay, with cloud in general, that's the selling point anyway. We don't have to maintain our infrastructure. But when I talk about this, I refer to managing cloud infrastructure. So if you've got VMs, for example, if you've got a service which is published to a background worker that's running in Azure, there's still a certain amount of maintenance that you are required to do. And it's still very much related to hardware spec, especially for virtual machines. And with serverless, of course, there is a server. Microsoft has the server in Azure's data centers. But for the purposes of your use case, you're not concerned about a server. You're purely concerned about the logic that you're executing in the cloud. You're only concerned with that particular function or that group of functions. So that's what serverless is. And it's becoming more and more mainstream, because the scalability of it is crazy. I think that you're charged based on transactions. So when you deploy a web service, like a headless service, which is doing scheduled actions in the cloud, then you're going to be paying specifically for the hardware usage. Whereas with serverless, you pay based on transactions, and it can get a little bit complex around the pricing, but it's definitely easier for smaller businesses that are looking to scale. So with functions, essentially blocks of code are being pushed into the cloud for later use. And again, that's not with a dedicated server resource. So the equivalents for Amazon Web Services would be Lambda. I'm actually not familiar with what the Google equivalent would be. I'm pretty sure they have one. But they are pretty standard now when it comes to generic cloud solutions, but they're super powerful. Essentially, it's like the equivalent of writing a really handy script that you can then just chuck into the cloud, and you're only really charged when it runs. It provides us some what we call on-demand compute resource. So again, that links back into what I was saying about pricing. It's only there technically when you need it. If you don't need it, it just lies dormant. And so that makes it extremely powerful. It's almost like spinning up workers as and when you need them. There's lots of different ways that you can trigger these functions, which I'll get into. But the popular ones, I'd say the most popular one is HTTPS or HTTP, however you want to refer to it, which essentially allows you to almost spin up a web endpoint that's only there when you need it. So I'll go into the detail with the export option, the export use case, sorry, but we're using that as a HTTPS triggered Azure function. And it's kind of like a sort of de facto API. I can just put something up there that says, if you call that, I'll execute my my logic. So it's a very useful trigger for things like webhooks, for example. If you need to bridge two systems together, you could say, okay, I'm using Sage, and I know that it can call a webhook. So I'll spin up an Azure function that can be called against, and I can execute my logic to bridge those two systems together. And then there's other types like queue insertion, when things change in a database. So you can take a very event-driven approach with Azure Functions, as you might do in your code. But that's really, really important, because in a distributed system, particularly when you have lots of different things happening that you need to then trigger things, an event-based system is critical, and Azure Functions can definitely offer that. Perhaps most importantly for me, in these use cases, they can trigger themselves on a schedule. So, as a more traditional back-end developer, I'm very used to writing services that are scheduled to spin up and do their thing and then disappear. I've written a lot of Windows services. I've written a lot of things that are scheduled within Task Scheduler on servers, but now actually that's a thing of the past for me, because I can just say, well, that lives in the cloud now and it runs every 5 minutes. So this bit is a bit more complex, but it's a really important point around Azure Functions. There's different types of state that exist with Azure Functions. And by that, I mean, you can have functions which are stateless. So they don't persist a lot of data. They don't change their state. They just spin up, work with the inputs they've got, and then they go away. And that's the more standard basic Azure function. But you can also have what's called a durable Azure function, which is something we've used for these use cases. And that does allow state to be controlled over a longer period of time, and it allows them to be asynchronous. So for longer running tasks, like if you've got something that needs to have several different states, depending on what the different variables are, a durable function is better, because you can have that long running task run, but Azure Functions also provides lots of different endpoints that you can check while that function is running. So you can say, how's the function going? What state is it in? You can tell the function to stop. You can tell the function to change what it's doing. So durable functions are more for if you've got longer running tasks and you want to be able to interact with them while they're running. So some example use cases. So I've touched on these a little bit already, but one of the classic use cases is the web API. So as I said, the traditional option, especially with .NET, was to create a Visual Studio web API project and then to publish that into the cloud. But you are potentially using up way more resource than you need to, especially if you're trying something out, if you're prototyping, or if your API is a sort of micro API. If it's something that only really does one very small thing, then potentially creating a web API and then putting it into Azure, it could be overkill. So a HTTP triggered function as a web API is a super solution, because you can just say, okay, here's my one endpoint, here's the logic that needs to run, and here are the inputs, and you've got yourself a web API. Reading and writing data from databases. So I think, as I mentioned in the last slide, one of the triggers is when things change in a database. So you may then have a function that wakes up and then takes that data, does something important with it. Maybe your event is financial. You might have a record which indicates that an order's come in and it's over $500,000, and that's significant. We need to tell somebody about that. So rather than trying to mess around with SQL triggers, which can be a lot of pain and suffering, I don't know whether you guys have been through that stuff, event-based triggers for Azure Functions can replace that, can jump into your database, whether it's in Azure, whether it's local to you, whether it's Microsoft SQL, whether it's a document database, doesn't really matter. It can dip into the database and fetch that data, or it can pass data into it. And quite importantly as well, we can leverage Entity Framework. So if you've got a DB context for that database, your Azure Functions can definitely use that. In fact, we do use that, as I'll demonstrate later on in the talk. And a really, really popular use case is queuing messages. So Azure is well, Azure and other cloud sources, cloud providers are really good at queues. They're really good at passing messages, in my opinion anyway. People might disagree, between services. It's the reason people have jumped more onto the microservices bandwagon, because the connectivity between services now is way easier to maintain and to build. And so you can create a message queue system in tandem with other Azure resources, if Azure is the service that you're using. So, for example, you might have a queue storage resource like we have that just simply queues up items in what's similar to blob storage and then processes those. Or you could be using something a little bit more advanced like Service Bus. But ideally as well, if you weren't necessarily putting all your eggs into the Azure basket, you may be using something like RabbitMQ. It's all possible. So queuing messages is a really huge use case. So let's get into the use cases that we actually implemented in at Nextbotics. So the first one I'll look at is for our dashboards. So we have an application, a web application, which is ASP.NET, and it uses an Azure SQL database. And it's multi-tenant in the sense that there's one application and there are separate databases for each customer. So when we have a new customer, we set them up with a new database and we use DNS resolution to essentially point them to the correct database, the correct connection string. And so you have the same experience through the same application, but depending on which URL you put in, you'll hit a different database. Now we have dashboards on those database on the app, and the data from that, as you can imagine, comes from an array of different sources. There's lots of different tables that are involved in reaching one specific analytic. And I don't know how experienced you guys are with SQL, but the more you join, the less optimal the query becomes. But also, it's not just the query itself, it's the fact that that data was having to be triggered, or the query for that data was having to be triggered as the page loaded. And what we were seeing was, as we were scaling out, as we were adding in more complex metrics, our page loading times were just dying. It was awful. And so we had to figure out a different way of doing it. We knew that we were going to have to pre-calculate the data, but we weren't really keen on creating scheduled tasks within the application itself. There's obviously some really good libraries for that, such as Hangfire, Coravel, to name a few. But we were more interested in how we could leverage Azure's offering. And so we hit upon functions for that. So what we essentially did with this is we took our Azure functions and we created lots of different scheduled function applications. And these are sort of really micro functions. It could be one function, for example, which is responsible for calculating the process outcomes that you see in the top left of that screenshot. There'd be another function which would be calculating the bot utilization in the bottom right. And really, those functions represent a single query. And what will happen is essentially on a rotating basis, on a regular interval, depending on the metric, the function will wake up and it will go into our DB context and say, give me all the tenants. Remember, this is a multi-tenant environment. Give me all the connection strings for the tenants that we have. And then for each of those tenants, each of those connection strings, I'm going to switch my DB context for Entity Framework to be looking into that specific tenant. And then I'm going to run the queries that need to be run through Entity Framework. So we're still benefiting from Link. We're not doing a lot of direct SQL queries, although we could if we wanted to. But we're quite happy that our Link queries are fairly optimized. But the key thing here is that this is happening all the time in the background, and that the data is then being dumped back into the database in its own table for pre-calculated analytics in a JSON format. So therefore, instead of loading the page and then kicking off loads of different queries that'll say, go get me this information for this metric, it just looks at the JSON, the data that's in that pre-calculated table, and then just renders it using charts.js. So there's a bit of a compromise with that. The benefit is that straight away the page loads, you've got the data. However, you have to accept, I guess, that it's not going to be accurate to the second like it probably would be had the page loaded with lots of different queries. But that was an acceptable compromise for us. We can schedule these functions every minute if we want to. So, we can specify that the data is accurate to the last minute, essentially. But it also allows us to take that further and benefit from Azure functions which trigger on database update. So once you've pre-calculated the data and it hits the database again to say, here's your nicely packaged up data for your metrics, well, then another function can say, well, reload the page. So send an event to the application and reload it. So then that gives us real-time updates that sort of counters a little bit of that delay that we'd be experiencing. For the second use case, we were using functions for exporting data out of our application. So one of the things we wanted to do was allow customers to not be restricted by the metrics we put in place. Obviously, we're very customer driven, so we like to put metrics in for them as they request them, but that takes a little bit of development time. In the meantime, if we can give them an opportunity to get the data out of the system and then they can manipulate it how they want to, then great. And everyone, customers still love spreadsheets. There's still no way around that. So the use case or the challenge we wanted to meet was give the ability to export this data from particular pages into Excel. So essentially the data can be extracted across any date range, and also this is really important. Because of that, because customers could choose a date range that started 2 years ago, and they may have automations which process documents, and that could be like maybe 100 documents an hour. You can imagine the data here starts to creep up towards big data territory, which could take some time. So we needed some kind of stopgap solution to this. We needed something that would run in the background and then tell the user, hey, your data's ready. That massive data export that you've requested, it's ready for you. You can download it. And that's where the Azure functions came in. But not just Azure functions, this required Azure durable functions because it would be a long-running task. So the use of Azure functions, durable functions, meant that we could allow that export to happen in the cloud and then have an asynchronous component. So it means that the application could call the function and say, here are my parameters. The user wants to have a report for this data point and it's this date range. And then the functions can then pass that off to other services, which then get the data in a similar way to what we were doing in the first use case to get the analytics. And then it can then create an in-memory spreadsheet and then put that back into a database queue in the tenant, which then triggers to say your download is ready. So here we're now bridging different systems, but allowing it to happen asynchronously. And that's how we were able to do it with durable functions.
Nick, sorry to interrupt. Just a quick question here that we have here in the chat. So the user is just asking if you are going to show any code in your demo.
Yeah, I am sorry. I can't do a code demo for this, unfortunately, because it's proprietary software. But happy to answer questions as much as I can. I mean, the next slide is an architectural diagram, so I can talk about how it's laid out. But by all means, if you want to get in touch with me after, I can figure out what I could potentially show. And also, I'm happy to take ideas for any videos you'd want me to build, which could demonstrate this as well.
Okay, sounds good. Thank you.
So this is actually my final slide, but I wanted to talk about the architecture in a bit more detail. So this is for the pre-calculation of data. So this kind of illustrates our multi-tenant environment a bit more and allows you to get an idea for how the data is traveling around the system. So each of these databases is an Azure SQL database. We have one master database, and that is the one that references all the different connection strings for our tenants. And then that obviously links into the child databases, each representing a different customer. And so in each of those databases, we have data that needs to be pre-calculated. So looking from the top, where you've got the master database, we've got there that every X minutes, an Azure function will get all the different tenant IDs into a list, and then it will run an iterative process over each tenant ID, adding that ID into a queue. And that queue then triggers the functions to switch the entity framework context to that specific tenant to gather the data, pre-calculate it, well, calculate it in that moment, and then to drop it back into the database as JSON so that it's available for the front end to simply render, essentially. So that's a visual view of how we're managing the infrastructure for this particular use case. So again, really sorry that I don't have actual code examples for you. Again, like I say, I'd be very happy to take any specific areas of Azure functions you'd like to see demonstrated, and then I'm happy to make videos on them. I've got quite a lot. I do actually have a couple of videos on Azure functions and Azure durable functions, which you can see on YouTube, so I'm happy to provide the links for those. But yes, unfortunately, I couldn't show you this specific code. And then, yeah, I'm happy to take any questions or any observations people have. Oh, Hugo, I don't know if you're on mute.
Sorry, the headset was pointing to the sky, as I used to say. Thank you very much. We definitely have here some comments, people saying that they are joining from Brazil and from Ireland. And also we have actually one question that just came up. So we have here Fernando just asking for the data export use case. How did you consider the cost of a durable function? How does it compare to spinning up a VM each time the user requests a big data export?
That's a good question, yeah. And that's certainly something you'd want to weigh up, because a lot of the time there is still a place for VMs to host these kinds of services. But I think the biggest benefit is the analytics available to us in the portal compared to running this on a VM. So by that I mean application insights, basically. So application insights can plug into Azure Functions and give you the amount of calls to specific functions. So I think this is more of an issue if you've got HTTP functions, because that is open to the user. So it could be exploited, or it could just be a victim of high traffic. But essentially, the telemetry you get in application insights is invaluable, because it will allow you to either scale out, so you can add more functions if you need to, although actually in most cases, Azure will do it for you, but it also allows you to cap that as well. So I'm pretty sure that in application insights, you can get a report or a trigger to say it's hit this level. Then you can start to look at scaling down your usage if you need to, or revising your pricing structures. If you're on a VM, it's still possible to do that, I think, but it's harder because that then relies on you working more as a Windows infrastructure engineer, because it's going to be a Windows server most likely, or a Linux server. And so you're going to have your own ways of tracking the traffic coming into your server and then using your service. So I'd say when I'm considering that, the winner for me is Azure Functions, because I've got way more data at my fingertips, and the pricing is actually really, really good. I think we'd have to double check because it does change often, but you have to be hitting quite a few transactions before you're actually charged in some scenarios. So you do get quite a lot of free processing depending on your use case.
Yeah, sounds great. Thank you very much, Nick. And actually, if you allow me, just some personal opinion on this. Another benefit of when you compare an infrastructure as a service against a platform as a service such as Azure Function is the fact that, remember, you have an abstraction on the scalability. So that means in an easy way, you have a user requesting a big data export. Probably you can parallelize the export and into multiple instances of the function. and this is abstracted from you. Whereas on the VM, you would need to write code to to parallelize all of this. You know what I mean? That's just a simple and a easy benefit that you can get from the function, essentially. Yeah.
Absolutely. Yeah. Another one that comes to mind as well, I've seen people using Azure Functions for static websites quite a lot as well. So it's quite a cost-effective solution if you're running a small website to run a static site, and you can host. I think you can host static Blazor apps in blob storage. You know, it's crazy what you can do. And so, you know, obviously that kind of restricts you with interactivity because you don't really have a backend to work with, but you could use Azure Functions as a backend. You know, you might have a very simple single page or landing page. The obvious example, I guess, is like a sign-up form. But say you need to have some pretty specific logic that fires to get that person signed up, then an Azure function can do all that for you.
Yeah, just an FYI as well on this is that static websites feature on Bob storage was available since, I would say, at least since 6 years old already. But this got replaced with Azure Static Web Apps. So the Microsoft recommendation is if you need to use to host a static web app, you can consider static web apps, which will provide you. And I think they still have the free tier available, so you can host for free there. And the static web apps, as Nick was saying, provides compatibility and connection with backends, which can be an Azure function or even your own API as well. Yeah. So it's great. It's great for you to host your personal blogs or websites if you need to. Yeah.
I guess as people mention these different use cases, I think of others, and another one that I think is amazing is where you've got legacy software that needs to benefit from some of the latest features in .NET. So obviously we've just had .NET 8 release, some pretty awesome performance benefits from C# in general. And say you've got a .NET framework application, which, you know, I've seen, or maybe it's a particularly old Java application or something like that. Being able to plug into an Azure function to benefit from that interoperability and use .NET 8 remotely, again, is another way of making it so that, you know, that might be the difference between a complete rebuild and something that carries you over a little bit, so that you can just start to benefit from the latest in .NET in just particular areas of your application.
Yeah, definitely. I would say Azure offers a lot of different service for your scenarios, and sometimes it becomes complex, to be honest, for you to pick the best service to use, and there is no right or wrong, you know what I mean? So it all depends on your requirements. Of course, for the functions, as Nick was saying, you can easily run functions, but you had, since the early days on functions, you had this issue of cold start. So that means you're running your functions in a shared environment. So consequently, when you are not using your functions get disposed and then needs reinitialization, some time to reinitialize again. And consequently, in certain scenarios, you cannot accept this cold start. So that means probably you need to go for functions premium, and functions premium, it's more expensive. So yeah, you know, you need always to assess the scenarios and the requirements in order to determine what is the best service, I would say. So yeah,
and that plays back into that scalability bit, doesn't it? Where you start with your basic first always. If there's any indie hackers here, use the free tier, and then you're always able to scale up. But by that point, you're actually generating revenue, so that's fine. It pays for itself.
Yeah. Okay, so we don't have any more questions in the chats. I just give a couple of more seconds for everyone. If you just want to share your questions, last-minute questions, we are still good to cover your questions. In the meantime, I just invite you. I'm going to share the link in the chat. Next week, we are going to have a really great session again by another Azure MVP. in this case Warner Chavez, that are going to talk and teach us all about generative AI and using Azure OpenAI, which is a great service that came up for you to use in case you need to use the OpenAI models. I'm going to just drop the link in the chat so you can access our website and sign up to the session next week. In the meantime, if you have any questions and if we just close the session, feel free to just drop the comments in the YouTube video, and I will share the link with Nick, and Nick will be available as well to just connect with you and answer any questions you may have in relation to this session. And of course, in the meantime, thank you very much for everyone that's just joined us. If you are watching this offline, feel free to just connect with us next week live, so you can connect with the speaker and raise your questions. And thank you very much, Nick, for your contribution and your session. And
Pleasure.
Have a great day. That's essentially what I have to say.
I'll just drop the links to my functions tutorials. So there's some code examples there as well that you can benefit from.
Perfect. Thank you, everyone.
Thanks, guys.
I'm going to just finish, and you can share the links there in the chat if you want, Nick.